To be useful, an amplifier has to have some type of input signal, and it has to have some type of load. So in this case, we have taken the 4 amplifier types and we have added a load that we call R sub L to each of them. Then what we've done is, if the input is going to be a current, in other words, if it's a current amp or if it's a trans resistance amp, we have added a Norton equivalent as the input. If the expected current or expected input is a voltage instead of a current, we have added a Thevenin equivalent here for the transconductance amp and the voltage amplifier. In the previous slide, we had said that for a current amp, we wanted R sub I, the input resistor, to be as low as possible. The idea here is that if it is as low as possible, we'll get as much current into R sub I and less current into R sub S, where it would not be amplified. In a similar manner, we also showed that for a voltage amplifier, we said that we'd like R sub I to be as high as possible so that the voltage drop across our source Thevenin equivalent would be minimal. In a similar manner, the transconductance amp, which relies upon a voltage to amplify, also we would like to see R sub I as large as possible. Now conversely, when we take a look at the output, if we have, let's say, a current amp, we would like to make R sub L as low as possible so that R sub O inside the amplifier gets less of the current. We get more useful current outside. This is the same thing that happens when we have a current amplifier or a current output in our transconductance amp. Meanwhile, if we take a look at those amplifiers which have a voltage as an output, we would like to see the R0 as low as possible. So once again, we have as much voltage across RL as possible. Taking a look at the inputs and at the sources now, notice that for the current amp, we have a current-controlled current source. For the trans resistance amp, we have a current-controlled voltage source. Meanwhile, for the voltage amp, we have a voltage-controlled voltage source. And for the transconductance amp, we have a voltage-controlled current source. So once you understand the pattern and the particular area where you want to get the power out, in other words, make R0 either very large if you are outputting a current, or make it very small if you are outputting a voltage, this will all start to fall into a pattern that is easily recognizable and easily recreated.